morning to everyone. Myself and Kalpana. I am from G.K.Jain Higher Secondary School, Royapur. Today, for the 11th standard, I am going to explain the topic is periodic classification of elements. In last video, we saw about a lot of scientists. They have been classified the elements. We know periodic table. It has been classified as block, P block, and D block as well as the F block. It is not obtained in the same day. It has been lot of efforts put by some other scientists. For example, Dobriner, they will be classified the elements as trades. That means if we have considered three elements, the sum of the middle element will be equal to the sum of the other two elements. So these are things will be there. And next we saw about the important definition. What is mean by atomic radius? What is that? How the electronic configuration has made? These are things. Now we have to see the electron affinity. Affinity means amount of energy released when an electron is added in the valence shell to form anion. I told that when the valence shell, the outermost shell will be called it as a valence shell. When it is able to attain the stable position, either it should be adding of electrons or removing of electrons. Okay, it has been done in a two ways. Either it should be added the electron or remove the electron, but it should be in a stable position. The valence shell should be in a stable position. Okay, for that, when we added the electron, we need the energy. That energy should be in a minimum quantity. That will be called it as a electron affinity. So electron affinity is nothing else. A minimum amount of energy is added for the adding of electron in the valence shell. Let's see how in the period wise as well as the group wise. Let's see the period wise. So I told that period means from left to right, and the group means from top to bottom. So totally we having 7 periods, and the group we having 18 groups are there. Let's see the electron affinity, how it should be happen in the period wise. In the period wise, it should be increased. I told that when the atomic sizes, it should be decreased in the period wise, because it has been most probably in the S shell and the P shell only. Okay, so whenever increasing the atom, the energy will be increased. Let's see here, it is the atom. Okay, it has been S shell, valence shell, and if it is having P shell, so along the period only you are having a S shell as well as a P shell, or some more it should be in the same shell only. Okay, so whenever increasing the proton, the atom size have been increased, so it should be nearly. So automatically what happen? Affinity will be in a decreasing way. The sharing will be decreasing way. Okay, so here what happen is, according to the left to right, the atom nucleus size will be in an increasing way. So automatically the amount of energy released it should be in an increasing order. We have to put a number of increasing the energy. The electron affinity, you should put a lot of energy to adding the electrons. That is why it should be increased. So along the period, the size should be decreased. So automatically the electron affinity, it should be increased. The same group wise, if you have seen the group, the electron size, it should be increasing more and more. So you have putting the energy, effort of energy will be decreasing way. So when it is difficult to adding the electron in the valence shell. And next one, electronegativity. Electronegativity means attract the shared pairs of electron towards itself. So that means the valence shell, the other outermost shell will be there. It is easy to attract towards itself. Those attraction property will be called it as a electronegativity. Okay, the same thing in a period wise and a group wise. In a period wise, the electron affinity will be increased because shorter in the atomic sizes. So whenever atomic sizes it has going increases, the shell will be so nearer to the shell only, isn't it? So that is why electron easily it can be attract towards. But in a group wise, it is difficult to attract because the shell has been extended more and more. That is why the affinity become decrease. Have you all understand? So when the shell become closer to that, so affinity, the outermost should be nearer to that. When you consider this is an electron, this is a nucleus, the outermost valence shell will be there. It is some more nearer. So easily it has been attract towards itself. But in a group wise, it has been more and more increased. So it should be difficult to attract towards itself. Okay, that is the difference. Let's see the valence or oxidation state. So valence, already told that it is a combining capacity. That is the same thing, oxidation state. The oxidation number of each different element having different oxidation state. It has been different according to the acceptance, according to the attracted towards itself. Okay, let's see that if you have seen the group, it should be like lithium, sodium, potassium, rubidium, all should be having the valence shell 1. So for example, lithium atomic number is 3. So if you have how to fill the shell, first shell it should be 2, the second shell it should be 1, so totally it should be 3. So outermost shell how many electrons having? Only 1, so valence is 1. Sodium 11, so first shell 2, for sodium it should be 11, first shell 2, second shell 8. Okay, so totally 10, and the last shell is 1. This is the electronic distribution of electron. So what is the valency of sodium? 1. So for the remaining in a group wise, almost it should be having the same valence shell. Let's see the period wise. If you seeing the period wise, lithium, beryllium, boron, carbon and nitrogen, they will be having a different valence shell, different number of ability of electrons will be there in that. And the next topic is effective nuclear charge. Okay, let's see that every atom, the center of the atom will be, nucleus will be present in it, and the electron should be revolved around it. Okay, for that, due to the electrostatic attractive force between the nucleus as well as the electron, it has to be attracted towards itself. So we cannot be able to find the valence shell. We can never find it the electrons revolved around it. So let's see that here it should be a nucleus. Here the electrons are revolved around it. If the gathering of electrostatic force, it has been attracted towards itself. We cannot able to distinguish between them. So finally what you have to do, some shell, that means the inner shell. Here the inner shell will be it will be act as a shielding. Let's see. So in between the nucleus and the valence shell, one inner shell will be there. So those inner shell will be acting as a shielding. It has been protected between the nucleus and the valence shell. Those will be called it as a effective nuclear charge, or it should be called it as a shielding effect. So shielding effect is nothing else. Some shell it should be act a protective layer between the nucleus as well as the valence shell. That will be called it. The formula for effective nuclear charge is Z minus S, where Z is the atomic number and S is the contribution of the effective nuclear charge. Let's see the example for that, how you have to find it. Let's see the effective nuclear charge of 4s and 3d. So it has been given the particular series. Okay, you have to find 4s and 3d of scandium. Let's see how you have to find it. How much of effective charge will be there. Okay, for the scandium the atomic number is 21. We have to do the electronic configuration for that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d1. Okay, so 2, 8, 10, 18, 20, 21. So totally it should be 21. First you have to find for 4s. So here it should be 3d. So leave the 3d. So it should be 4s. So 4s it should be 1, n, and sp, 3 orbital should be n minus 1. 2s2, 2p, 2 orbital should be n minus 2, and 1s2 it should be n minus 3. Let's see how it should be do. Group, you have to make it a tabular column. Group, number of electron, contribution of s shell, particular of s electron, where n, here it should be n. 1 will be there, only 1. So it should be the numbers. So 1 means it is the constant value will be given there. So 1 into 0.35, 0.35. Let's do n minus 1. So n minus 1 is 8 and here minus 1. So it should be plus 1. So it should be 9. So 9 means n minus 1 equal to 9. 9 into 8.5, 0.85 is 7.65. N minus 2 and the other, n minus 2 and the other will be, as well as the n minus 3, it should be 10. Okay. So it should be the value of 1. If it is 1 means the constant value 0.35, 0.85, 1, it should be a constant value. For whatever it is, it should be there the same value. We have to multiply and put it. As we have sum of the total, we get it 18. Next we see the 3D, the same thing. Here what happened, we have to leave the 4s. You have considered 3D as a n. Here 3D has a n minus 1 and n minus 2, n minus 3 and other. The same n, where n equal to 0, because only one electron will be there, it is present in the outermost shell. So it should be 0. And next one, value of 0 is 0 and 1 should be 0.35. So 0.35. More than 10 it should be 10 and more than 10 it should be 1. So for 0 you have to 0.35. For 18 it should be 1. Altogether it should be 18. So 0 into 0. 18 into 1, 18. So finally the contribution of the effective will be 18. So Z effect equal to shielding effect. Shielding it should be 18. Z equal to 21 atomic number, and yes, totally here we have find it 18. So 21 minus 18 equal to 3. So the effective nuclear charge for scandium will be 3. This is the way you have to finding the thing. So before you should be know the atomic number, the configuration, and in the question itself they have given particularly, and you have to by heart those numbers also. It is a constant number. Then you have to easily substitute the value you have given. So in this periodic classification, the expected questions are according to the scientist, how the electrons are, how the periodic tables have been classified. This is the one type of questions. And next one, important definition: atomic radius, ionic radius, effective nuclear charge, electron affinity, electronegativity. How? First they have asking the definition alone, then along the variation of period and group. For example, define atomic radius, you should given the definition, and along the period how the atomic radius have been different, along the group how it should be different. And next one is the, so definition is all important, very important one. And next one, effective nuclear charge. Most probably they have given the problems, we have expected the problems alone. Thank you.